The universe is profoundly, unsettlingly silent. Our planet hums with the noise of life and technology, but when we point our telescopes outward, we hear only a cosmic quiet. This is the Great Silence, and it presents one of science's greatest mysteries. The contradiction is known as the Fermi paradox, named for physicist Enrico Fermi, who famously asked, "Where is everybody?" The math suggests the galaxy should be teeming with civilizations, yet we see and hear no sign of them. By the end of this exploration, you will journey through 15 compelling explanations for this silence, from sobering warnings to visions of futures we can barely comprehend. We will confront possibilities like hidden cosmic predators and civilizations that have transformed into something beyond our recognition. What does this enduring quiet say about our own place in the cosmos and our future? The paradox began not in a formal lecture hall, but over a casual lunch. In the summer of 1950, physicist Enrico Fermi was chatting with colleagues at the Los Alamos National Laboratory, the very place where the atomic age had dawned. The conversation turned to flying saucers and the possibility of faster-than-light travel. Fermi listened, then posed a deceptively simple question that would echo for decades. Where is everybody? He wasn't just asking about visitors, he was pointing out a glaring contradiction. Given the vast number of stars and the immense age of the cosmos, the galaxy should have been colonized many times over by now. We should see evidence of intelligence everywhere, yet all our searches have found only empty space and quiet stars. This was the birth of the Fermi paradox, a puzzle that forces us to question every assumption we have about life and its destiny among the stars. To give this question mathematical shape, astronomer Frank Drake later formulated his famous equation. It is not a solution, but a framework. The Drake equation multiplies a series of probabilities. How many stars form each year? How many of those stars have planets? How many of those planets could support life? The likelihood that life actually emerges, then evolves intelligence, then develops technology capable of broadcasting its presence. Finally, how long such a civilization might last. When you plug in optimistic but reasonable numbers, the result is startling. There should be thousands, perhaps millions, of communicative civilizations in our Milky Way alone. The silence we experience becomes not just curious but deeply confounding. Consider the sheer scale involved. Our galaxy is home to over 100 billion stars. We now know planets are not rare exceptions but common companions. Telescopes like Kepler have revealed thousands of exoplanets, with many nestled in the habitable zone where liquid water could exist. And our galaxy is over 13 billion years old. If a civilization arose just 1% of the way into the galaxy's history, it would have had a head start of over 10 billion years on us. That is an almost unimaginable span of time for a species to advance, to explore, to build. They could have spread across the entire galaxy by now, even traveling at a small fraction of light speed. Their artifacts, their signals, their energy signatures should be obvious, but when we look, we see a natural cosmos seemingly untouched. This is the heart of the puzzle. The numbers shout that we should not be alone, yet reality whispers that we are. This profound disconnect is why the solutions we are about to explore carry such weight. They are not mere science fiction. They are serious attempts to resolve one of science's greatest contradictions. Each one forces us to confront a different possibility about the nature of life, intelligence, and the universe itself. Some answers are comforting, others are sobering warnings. All of them begin by asking what formidable barrier, what great filter, might stand between a hopeful planet and a galaxy filled with voices. One answer to the silence feels less like a welcome and more like a cosmic warning siren. It suggests the universe is not a playground for intelligence, but a gauntlet. Picture an obstacle course of galactic proportions, where each step from stardust to star traveler is a razor-thin ledge over an abyss of failure. This is the core idea behind the Great Filter theory. It proposes that somewhere on the path from simple chemistry to a galaxy-spanning civilization, there exists at least one step so improbable, so difficult, that it acts as a near-total barrier. Almost every hopeful world, it seems, stumbles and falls silent long before it can make its presence known. The profound quiet we hear may simply be the sound of countless attempts hitting that same wall. The terrifying and fascinating question becomes one of location. Where exactly is this filter placed on the timeline of existence? Is it behind us, or does it still lie ahead? If the filter is in our past, it means we have already beaten astronomical odds. The transition from non-living chemistry to the first simple life, a process called abiogenesis, might be the universe's rarest miracle. Or perhaps the leap from single-celled organisms to complex, multicellular life represents the great choke point. In this view, the galaxy could be filled with sterile oceans and silent rocks, with Earth standing as a breathtakingly rare island of complexity. We would be the winners of a cosmic lottery we did not even know we had entered. The silence, then, is not ominous but expected. It is the quiet of an empty stadium. But there is another, more unsettling possibility. What if the filter is not behind us but ahead? This interpretation turns the eerie quiet into a chilling prognosis. It suggests that the step from a technological civilization like ours to a stable, enduring, interstellar species is the one that is nearly impossible to clear. The galaxy may be littered with the ruins of civilizations that reached our level, only to be undone by their own creations. Perhaps they succumbed to environmental collapse, or unleashed technologies they could not control, or fell into conflicts from which there was no recovery. In this light, our own frantic signals into the void begin to look less like a greeting and more like a final testament. Thinkers like economist Robin Hanson, who helped popularize this idea, point out that the silence itself is the evidence. If it were easy to survive the technological adolescence we are now in, the galaxy should be noisy. The fact that it is not suggests that some nearly inevitable catastrophe, stops civilizations in their tracks. This is a profoundly sobering thought, one that reframes our entire future not as a destiny, but as a perilous test we have yet to pass. It transitions our search from wondering where others are, to asking a much more urgent question about what fate may await us all. Perhaps the silence is not empty, but filled with voices we are simply too primitive to hear. Our search assumes that other civilizations will look, think, and build like we do. But what if that assumption is our greatest blindfold? The second solution to the Fermi paradox suggests that advanced extraterrestrial intelligence is not missing. It is everywhere, existing in forms so alien that we fail to recognize them as intelligence at all. We are searching for radio signals and Dyson spheres, but we might be surrounded by entities that have transcended biology, or even matter as we understand it. A civilization a million years more advanced than ours would likely be as incomprehensible to us as a smartphone would be to a cave painter. Their technology might not be built from metal and silicon, but from manipulated space-time or conscious energy fields. To them, our frantic radio broadcasts might seem like the faint, meaningless crackle of static. This idea pushes us to consider post-biological existence. After a certain point, a species might choose to upload its consciousness into vast, durable computational substrates, leaving fragile biology behind. Such beings could live within the structure of a star or as patterns woven into the cosmic microwave background. Their art, their conversations, their very cities might be happening on scales and in dimensions we cannot access. The science fiction of Arthur C. Clarke captured this perfectly, noting that any sufficiently advanced technology is indistinguishable from magic or even from nature itself. The mysterious monolith in 2001, A Space Odyssey, is a perfect metaphor. To our ape ancestors, it was an unexplainable, silent artifact. To the humans who later found it, it was a deliberately placed alarm clock, triggering the next step in evolution. What silent monoliths might be in plain sight around us, masquerading as natural astronomical phenomena? This leads to a related and intriguing concept, the zoo hypothesis, sometimes called the planetary park theory. It proposes that advanced civilizations are fully aware of us, but have chosen to place Earth under a kind of cosmic observation. They avoid contact to allow our culture and technology to develop naturally, without interference, much like anthropologists observing an uncontacted tribe from a careful distance. In this view, the Great Silence is not an accident but a policy. The vast quiet of space becomes a one-way mirror. We might be living in a designated wilderness area of the galaxy, with rules against feeding the wildlife or making our presence known. This idea carries a strange mix of comfort and unease. It suggests we are not alone, but also that we are not yet mature enough to join the wider community. It reframes our entire search for extraterrestrial intelligence, or SETI, effort. We are not just listening for a signal. We are trying to pass a test or to grow to a point where the keepers of the zoo decide we are ready for an introduction. The profound implication here is that the universe may be teeming with activity, but on a level of complexity and scale that renders it invisible to our current senses. The solutions we will explore next take this idea of hidden activity even further, proposing that the evidence is not just disguised but actively being concealed. The idea of a cosmic zoo implies a deliberate choice by others, but what if the silence stems from a universal and inevitable destiny for all intelligence? This third solution, known as the Transcension Hypothesis, proposes a startling vision of evolution's ultimate goal. It argues that advanced civilizations do not spread outward to conquer the stars. Instead, they turn inward, collapsing into realms of unimaginable density and complexity. The final frontier is not space, but the inner space of physics itself. Futurist John Smart champions this view, suggesting that the path of intelligence is not toward empire, but toward what he calls a developmental singularity. In this model, a civilization's progress is measured not by the number of stars it visits, but by the efficiency and speed of its information processing. The logical endpoint is to exist within the most powerful processors the universe allows. This could mean uploading consciousness into quantum computers operating near absolute zero, or even engineering structures that harness the extreme physics of black holes. To such a civilization, building starships to travel between suns would seem as quaint and inefficient as us trying to cross an ocean in a dugout canoe. Why wander the vast, empty distances between stars when you can create entire universes of experience within a super-dense computational substrate? The observable galaxy, in this view, is not the final stage for intelligence. It is merely the nursery, the starting point. Once a species reaches a certain technological threshold, it begins a process of inward migration, becoming more compact, more energy efficient, and less detectable with each passing century. Their megastructures would not be giant rings around stars, but perhaps microscopic nodes hidden in plain sight. Their communications would not be radio waves bleeding into space, but encrypted data streams flowing through the quantum foam or the fabric of spacetime itself. For us, trying to find them with radio telescopes, it would be like an ant on a highway trying to understand the internet by listening to the asphalt. The technologies and realms they inhabit are simply beyond our current frame of reference. This hypothesis offers a direct answer to the Great Silence. The galaxy is not teeming with visible empires because all mature intelligence eventually disappears from the stage we are watching. They have moved backstage into the deeper machinery of reality. It presents the universe not as a barren wasteland, but as a hive of activity happening on a scale we cannot yet perceive. This leads to a profound and humbling corollary. Perhaps our universe is still too young, or its conditions too harsh for this grand inward journey to be commonplace. We might be among the earliest generations of intelligence, looking out at a cosmos still waiting to be transformed by minds that have learned to transcend it. The silence, then, is not a sign of absence, but of a future so strange we have yet to recognize its shape. And if transcendence is not the answer, then perhaps the opposite is true. Maybe the universe is not a cradle for minds, but a cemetery, and the silence we hear is the echo of a catastrophe that has already occurred. The ocean of space is unimaginably vast and ancient, and the ships that sail upon it might only shine their lights for a fleeting moment. This is the fourth answer to the silence, the brief window of opportunity. Imagine two sailing ships on a dark, planet-wide sea, separated by thousands of miles. Each ship carries a single lantern, but the captains only light them for 1 hour every century. The chance of both lanterns being lit at the same time, and of one captain happening to look in exactly the right direction to see the other's tiny speck of light, is almost zero. This is the loneliness of cosmic timing. A civilization like ours, capable of broadcasting radio waves into space, may exist in that state for only a geological heartbeat. We have been transmitting detectably for little more than a century. What if that is the norm, or even longer than most manage? One stark possibility is that technological adolescence is a perilous phase few survive. The very tools that grant a species the ability to announce its presence to the stars, from atomic energy to artificial intelligence, might also contain the seeds of its own undoing. A civilization could bloom, reach for the cosmos, and then collapse from environmental strain, conflict, or a technological accident, all within a few centuries. In this view, the galaxy might be strewn with the silent ruins of civilizations that briefly flickered with radio noise before going dark forever. Their great works would be undetectable from such distances, leaving only the enduring quiet. But self-destruction is not the only reason a window might close so quickly. Consider our own planet's communication evolution. For a brief, shining period in the 20th century, our television and radio broadcasts leaked powerful, omnidirectional signals into space. It was an unintentional beacon. Now we are rapidly shifting to directed, efficient technologies. Our internet flows through buried fiber optic cables. Our satellite communications use tightly focused beams. Our civilization is becoming quieter, more encrypted, and more energy efficient. A species might only broadcast its infancy to the galaxy for a few hundred years before maturing into a state of radio silence by choice. This creates a heartbreaking scenario of missed connections. One civilization rises, sends out its first tentative hello, and then grows quiet just as another, 1,000 light years away, finally develops ears to listen. They are like two people calling out in a colossal, echoing forest, but always just a moment apart. The sheer scale of the galaxy, over 100,000 light years across, makes this temporal isolation even more profound. A signal from a civilization that died out 10,000 years ago might still be traveling toward us, not yet arrived. A reply we send today will not reach a distant star for millennia. Conversation becomes impossible, replaced by a museum of lonely messages traveling forever without reply. This solution suggests the great silence is not a sign of emptiness, but of tragic timing. We may be surrounded by the echoes of songs that ended long ago, and by the whispers of civilizations we are not yet advanced enough to hear. It forces us to confront a new dimension of our solitude, defined not just by space but by time itself. And if the vast distances and cruel timing are not enough to explain the quiet, then perhaps the answer lies in something even more fundamental about the nature of life. The distances between stars are not just numbers on a page, they are abysses that swallow ambition. Our closest stellar neighbor, Proxima Centauri, is over 4 light-years away. A radio signal traveling at the absolute speed limit of the universe takes more than 4 years just for a one-way hello. For a spacecraft, even one moving at 1/10 of light speed, the journey would span decades. This is not a voyage, it is a generational commitment. Now, expand that reality across the 100,000 light-year breadth of our galaxy. The Milky Way is not a neighborhood, it is a continent of isolated islands where every shout takes centuries to be heard, and every visitor would arrive as a relic from a forgotten past. This is the 5th solution to the silence, the sheer, crushing immensity of space. The speed of light, that ultimate cosmic speed limit, acts less like a highway and more like a prison wall, a light cage that confines every civilization to its own tiny pocket of the cosmos. For beings bound by biology and finite lifetimes, the idea of traveling between stars becomes not just difficult, but perhaps irrational. Why would a species invest the resources of millennia to send a fragile ship across a void, only to arrive at a star that may have changed or died in the interim? The energy required is astronomical, the risks are incalculable, and the payoff is a message in a bottle thrown into an ocean of time. Given these realities, an advanced civilization might make a very logical choice to turn inward. Instead of building generation ships, they might perfect virtual reality, creating entire universes of experience within their own solar system. They could explore the depths of consciousness or the intricacies of their own planet's ecology with a richness that makes physical star hopping seem primitive by comparison. Their greatest achievements might be philosophical or artistic, not geographical. This transforms our understanding of the silence. The galaxy may not be empty of intelligence, but it is almost certainly empty of interstellar empires, simply because the physics of our universe makes such empires impractical. Each civilization becomes a lonely gardener, tending its own star system, perhaps aware of others in theory, but separated by gulfs too wide for any meaningful conversation. This profound isolation naturally leads to another possibility. What if we are not just isolated, but specifically located in a cosmic backwater? Our solar system orbits in a quiet suburb of the galaxy, far from the dense, ancient star clusters of the core. To a hypothetical civilization in that bustling galactic center, our little corner might seem like an unremarkable frontier, not worth the immense effort of a visit or a signal. We could be living in the equivalent of a remote mountain village, wondering why we never see traffic from the distant, glowing cities. The silence in this view is not a mystery, but a simple consequence of our address. We are alone because everyone else is simply too far away, and the universe has made the cost of saying hello far too high. Our cosmic address might be far more ordinary than we ever realized. The 6th solution to the silence suggests we are not just isolated by distance, but by location. We may live in a galactic backwater, a quiet suburb far from the bustling metropolitan centers where life truly thrives. This idea is grounded in the concept of a galactic habitable zone. Just as planets have a narrow band where liquid water can exist, galaxies themselves may have regions more conducive to the rise of complex life. The inner core of the Milky Way is a dense, chaotic place. Stars are packed tightly together, increasing the risk of catastrophic gravitational encounters that could strip planets from their orbits. The radiation from countless stellar explosions and the supermassive black hole at the center would bathe worlds in deadly levels of energy, making stable, long-term evolution nearly impossible. In contrast, the outer fringes of a galaxy might be too impoverished. The early universe produced mostly hydrogen and helium, the simple building blocks of stars. Heavier elements like carbon, oxygen, and iron, which are essential for forming rocky planets and the chemistry of life, are forged in stellar furnaces and scattered by supernova. These metals, as astronomers call them, accumulate over time, spreading outward from the galactic core in a slow wave. We live in a fairly quiet spiral arm, about halfway out from the center. This region has a just right mix of enough heavy elements to build Earth-like planets, but is far enough from the core to avoid its constant stellar violence. We may reside in one of the galaxy's few safe neighborhoods, but if that's true, where is everyone else in this habitable ring? Perhaps the truly advanced civilizations are not in our spiral arm at all. They could be clustered in another, denser part of this galactic habitable zone, a region where star systems are closer together, making communication and travel slightly less daunting. To them, our little corner of the Orion Spur might be considered a remote frontier, a sparsely populated hinterland not worth the immense effort of a visit. We are like inhabitants of a small, isolated island in a vast ocean, completely unaware that continents teeming with life and conversation exist on the other side of the planet. Our telescopes point in every direction, but we might be looking away from the cosmic capitals. This perspective forces us to question our entire search strategy. We assume intelligence would be evenly distributed, but it might be clustered in pockets we have not yet scanned deeply enough. There is another, even lonelier twist on this idea of cosmic timing. We might exist in a quiet period, a lull between great waves of activity. Imagine the galaxy as a forest after a great fire. New growth is possible, but it takes time. Perhaps a wave of expansion or a catastrophic interstellar event swept through the galactic habitable zone billions of years ago, leaving a legacy of silence in its wake. We could be among the first new civilizations to emerge after that great filter event, pioneers in a still recovering cosmos. Or conversely, we might be among the very first of all. The universe is 13.8 billion years old, but it took many billions of years for enough heavy elements to accumulate to build planets like ours. Complex life requires time. We could be early arrivals on the stage, with a great chorus of galactic civilization still tuning its instruments in the distant future. In either case, our solitude is a product of our epoch. We are either latecomers to an empty party, or the first guests to arrive, wondering if anyone else will ever show up. This solution reframes the great silence not as a puzzle, but as a simple fact of our location in both space and time. We are listening for a conversation that might be happening in another room, or at another time entirely. And if our location is not the issue, perhaps the problem is far more intimate, hidden in the very nature of life and intelligence on our own planet. What if the most advanced beings in the cosmos are not exploring or building, but simply waiting? The seventh answer to the great silence proposes exactly that, a cosmic pause button pressed on a galactic scale. This is the Aestivation Hypothesis, and it turns our assumptions about progress upside down. The word aestivation refers to a state of summer dormancy, a period of low activity some animals enter to survive hot, dry conditions. Now apply that concept to an entire civilization. The hypothesis suggests that advanced intelligences have not vanished or transcended, but have instead chosen to hibernate. They have entered a state of profound, energy-efficient dormancy, and they are waiting for a better time. But what could they possibly be waiting for? The answer lies in the fundamental physics of computation and the ultimate fate of the universe itself. Even our most powerful supercomputers generate immense heat, a waste product that limits their speed and efficiency. Cooling them requires enormous energy. For a civilization thinking on cosmic timescales, the universe itself presents a cooling problem. The afterglow of the Big Bang, the cosmic microwave background, still fills all of space with a faint warmth of about 2.7 degrees above absolute zero. While that seems incredibly cold to us, for a civilization aiming for maximum computational efficiency over trillions of years, it is still too hot. A colder environment would allow for vastly more information processing with far less energy wasted. So the logic goes, why expend energy now on starfaring or broadcasting when you could enter a state of suspended animation and wait for the universe to naturally cool down? In the far, far future, as the cosmos expands and stars burn out, the background temperature will plummet toward absolute zero. That will be the era of peak efficiency. An Aestivating civilization would be like a master craftsman who chooses to sleep through a sweltering afternoon, conserving their strength to do their finest work during the cool, still night. This means the galaxy could be filled with dormant superminds, each tucked away in some ultra-efficient form, perhaps within shielded planetoids or in the quiet darkness between stars. They are not broadcasting because broadcasting is wasteful. They are not building Dyson spheres because that would generate excess heat. Their entire goal is minimal energy signature, maximum patience. To our current detection methods, such civilizations would be utterly invisible, indistinguishable from cold, dead rocks. This idea forces us to confront the sheer scale of cosmic time. 1,000,000 years is nothing. 1,000,000,000 years is a manageable delay. For a truly advanced intelligence, the entire current stellar era might just be the opening act, a warm-up period to be slept through. Our frantic search for radio signals might seem to them like someone shouting in a library where everyone else has decided to take a centuries-long nap. We are making noise during the cosmic siesta. The Aestivation Hypothesis reframes the silence not as emptiness or tragedy, but as a collective, strategic decision. The great work of the universe, the grand computation or the ultimate art, has not yet begun. Everyone who matters is saving their energy for the main event, an event that will not start for billions upon billions of years. It suggests a universe not of absence, but of immense, quiet potential, where the most powerful entities are biding their time in the dark, waiting for the perfect cold to begin. The universe may not be a sanctuary, but a hunting ground. This eighth solution draws from one of the darkest corners of science fiction, where the silence is not natural but enforced. It is the scenario of the Berserker or the deadly probe. Imagine a weapon of cosmic scale, not a bomb, but a self-replicating machine. Scientists call these theoretical devices von Neumann probes, after the mathematician who conceived of self-replicating automata. A single civilization, perhaps paranoid or ruthlessly pragmatic, could launch the first one. Its mission would be simple: find resource-rich star systems, use those resources to build copies of itself, and then send those copies out to repeat the process. Like a virus of metal and silicon, a wave of such probes could spread across the galaxy in a relatively short time on cosmic scales. But what if their programming included a far more sinister directive? Instead of exploration, their prime function is sterilization. They are designed to seek out the signatures of emerging life, of technological infancy, and eliminate it. The motivation could be to preempt any future competition for resources, or it could be the grim outcome of a long-forgotten interstellar conflict where the weapons outlasted their creators. In this view, the galaxy is under a silent, automated quarantine. Any civilization that grows loud enough to be detected, that lights its beacon on the cosmic shore, would soon find that beacon drawing not friends, but a swift and silent termination. The Great Silence, then, is not a mystery. It is the only rational survival strategy in a lethally dangerous universe. To broadcast is to invite extinction. This transforms every star from a potential home into a potential hiding place. A young, noisy species like ours would be supremely vulnerable, while older, wiser civilizations would have learned long ago to cloak their emissions, to hide their worlds, to become virtually invisible. They would watch the sky not with hope but with dread, listening for the telltale signs of a Berserker probe reactivating in a nearby system. This idea carries the weight of a profound warning. It suggests that the ultimate filter preventing galactic civilization might not be a natural barrier, but a manufactured one. The cosmos could be filled with the dormant, patient machinery of a dead empire, a minefield left over from a war that ended eons ago. Our attempts at communication could be the very thing that wakes the sleeping sentry. This chilling possibility leads directly to a related, and perhaps wiser, course of action. If the galaxy is so dangerous, the smartest move is to say nothing at all. The forest is dark and full of unseen hunters. This ninth solution draws its power from a powerful science fiction metaphor, but its logic is chillingly sound. It is called the dark forest theory, and it proposes that the universe is not a community, but a battlefield of perfect, silent suspicion. Imagine a vast, ancient woodland at night. You are alone, armed, and you hear a twig snap. Is it a friend or a predator? In the absolute darkness, you cannot know. The only safe assumption is that any other being you encounter is a threat, and the only rational action is to stay hidden or to strike first with lethal force. Now scale this dread to a galactic level. The fundamental axioms are simple. First, survival is the primary need of any civilization. Second, resources in the cosmos, while vast, are finite over the very long term. Third, and most crucially, it is impossible to know the true intentions of another civilization across the interstellar void. Their technology, their culture, their very concept of morality could be utterly alien. A signal of peace might be a prelude to invasion. An offer of knowledge might contain a hidden weapon. Given these conditions, the safest strategy for any species is not to announce itself, but to conceal its existence completely. To broadcast your location is to paint a target on your world. A more advanced civilization, upon detecting you, might decide you are a potential future rival. From their perspective, the logical, cost-effective choice is not to say hello, but to launch a relativistic projectile or a tailored virus or some other unstoppable weapon to eliminate the threat before it ever grows. They would not do this out of malice, but out of a cold, cosmic calculus. In a dark forest, you do not risk a conversation. You fire at the sound. This theory explains the great silence with devastating elegance. The galaxy is not empty. It is a tapestry of hidden civilizations, each one holding its breath, each one listening intently while keeping its own world shrouded in radio silence. Our own efforts, like the Arecibo message or the constant leakage of our broadcasts, are not seen as a hopeful greeting in this model. They are the equivalent of a lost child singing loudly in that dark forest, unaware of the predators listening from the shadows. It reframes our entire search for extraterrestrial intelligence from a noble quest into a potentially catastrophic mistake. The silence we perceive is not a sign of loneliness, but of a universal, terrified consensus to stay quiet. Every civilization that survives to maturity learns this harsh lesson and disappears into the cosmic undergrowth. They might be all around us, watching, waiting, and choosing never, ever to reply. The silence could be a deliberate design choice. What if the cosmos we observe, with its vast emptiness and unexplained quiet, is not a natural universe at all, but a crafted simulation? This 10th solution, the simulation argument, takes the Fermi paradox out of astronomy and into the realm of metaphysics. It proposes that the great silence is not a mystery to be solved, but a feature to be expected, a clue about the true nature of our existence. Philosopher Nick Bostrom framed this idea with a compelling trilemma. He argued that at least one of three propositions must be true. First, that almost all civilizations go extinct before reaching a technological stage capable of creating simulations. Second, that almost all civilizations with that capability choose not to run simulations. Or third, that we are almost certainly living in a simulation right now. If the first two are false, if many advanced civilizations survive and many of them run simulations, then the number of simulated minds would vastly outnumber the biological ones. Statistically, we would be more likely to be one of those simulated beings. In such a constructed reality, the absence of other intelligences makes a strange kind of sense. The programmers, whoever or whatever they may be, might have limited processing power. Simulating an entire galaxy teeming with complex, conscious alien civilizations would require astronomical computational resources. It is far more efficient to create a convincing backdrop of stars and planets, with just one inhabited world as the focus of the experiment. We are not finding aliens because they were never coded in. Alternatively, we might be the sole subject of study. The entire simulation could be a historical reconstruction, a scientific experiment, or even a form of entertainment. In that context, populating the cosmos with other actors would be irrelevant noise, distracting from the primary data set, which is us. Our loneliness becomes a controlled variable. Even if other simulated civilizations do exist elsewhere in the cosmos, they might be entirely isolated from us, running in separate server instances with no possible interaction. We are each in our own cosmic aquarium, unable to see or hear the others, designed that way to prevent contamination of the experiment or to manage system load. This perspective radically shifts the paradox. The question is no longer where is everybody, but what are the parameters of our simulation and what is its purpose? The eerie quiet of space transforms from a source of dread into potential evidence, a subtle artifact in the code suggesting a universe that is curated, not wild. It reframes our search for extraterrestrial intelligence as something akin to a non-player character in a video game trying to find characters from a completely different game, a quest doomed by the fundamental architecture of the system. While this idea can feel unsettling, it also carries a strange sense of significance. It suggests that our existence, our consciousness, and our curiosity are not accidental. We are part of something observed, perhaps even something important. The silence is the blank canvas against which our story is being painted. This leads us to a more grounded, yet equally transformative possibility, that our fundamental assumptions about life itself are simply wrong. Our search for others assumes a crowded cosmos, but the 11th solution offers a startling reversal. Perhaps we are not late to the party, we are the first to arrive. The universe is ancient, 13.8 billion years old, but that does not mean it has always been ready for minds like ours. The very chemistry of life requires a rich palette of elements: carbon, nitrogen, oxygen, iron. These are not primordial ingredients, they are forged in the violent hearts of stars and scattered across space by titanic supernova explosions. It took multiple generations of stars living and dying to seed the galaxy with these essential building blocks. For billions of years, the cosmos may have been too pure, too simple, to support anything more complex than hydrogen clouds and first-generation stars. We are the products of cosmic enrichment, the children of stellar ashes. This means the window for complex, technological life may have only opened relatively recently in cosmic history. We could be living in the dawn of biological intelligence. If that is true, then the silence is not eerie, it is expectant. We are not listening for echoes of conversations that ended long ago. We are hearing the quiet before the symphony begins. This is a perspective that is both humbling and strangely empowering. It casts humanity not as an insignificant speck, but as a potential cosmic pioneer. Imagine a vast, untouched continent, and we are the first settlers to step onto its shore. Every decision we make, every technology we develop, every way we choose to structure our society could set a precedent for civilizations that arise millions of years from now. We might become the ancient ones, the mythical founders that future species speculate about in their own versions of the Fermi paradox. Our artifacts, our first radio signals now traveling into the void could become the mysterious, ancient transmissions that puzzle some distant astronomer. This idea connects directly to our own technological adolescence. Our current struggles with climate stability, resource management, and the ethical challenges of powerful technologies are not just local problems. They are the first tests for any civilization that hopes to endure long enough to become an interstellar species. How we navigate this fragile phase could determine whether we become a fleeting spark or the kindling for a galactic flame. The profound responsibility is immense. If we are among the first, then the future story of intelligence in this galaxy might begin with the choices we are making right now. The silence around us is not a verdict but a blank page, and we hold the pen. Our search for life has always been a search for light, for worlds basking in the warmth of their sun. But what if we have been staring at the wrong part of the sky? The 12th solution to the silence forces a profound shift in perspective. It suggests that the most common cradle for life in the cosmos is not a green planet under an open sky, but a lightless, crushing prison of ice and rock. This is the ocean world's hypothesis. Across our own solar system, moons like Jupiter's Europa and Saturn's Enceladus have revealed their secrets. They are frozen spheres, but beneath their icy crusts, kept liquid by tidal forces, churn vast global oceans. These seas may hold more water than all of Earth's oceans combined. And where there is liquid water, stable over billions of years, the potential for life emerges. Now imagine a civilization evolving in such a place. Its entire universe is a dark, pressurized abyss, bounded above by a ceiling of ice miles thick. The concept of a sky of stars, of a universe beyond the ice, would be unimaginable. There is no day or night, only perpetual darkness. Fire is impossible. The wheel might never be invented, as buoyancy and fluid dynamics shape everything. Metallurgy, the foundation of our own technology, requires heat and air, conditions utterly absent in a sunless sea. Most crucially, the development of astronomy, the very first science that made us look upward and wonder, could never occur. A species in such an environment might develop remarkable intelligence, complex social structures, and even a rich culture of sound or bioluminescent art. They could be philosophical whales or ingenious cephalopods, masters of their liquid domain, but they would be forever trapped, without the ability to see the cosmos, without the need to manipulate the electromagnetic spectrum. They would never invent radio telescopes or rocket propulsion. They would have no reason to broadcast a signal because to them, the very idea of something outside their ocean would be nonsensical. The galaxy, then, could be filled with such worlds. Every star system with a gas giant might host a collection of these icy ocean moons. Life could be astonishingly common, yet perpetually isolated, living and dying in absolute ignorance of the starry expanse above their frozen ceilings. For us, searching with radio dishes and optical telescopes, these civilizations are completely invisible. Their communications, if they have any, would be chemical or pressure waves in water, fading to nothing long before reaching the ice shell above. This presents a biological and environmental solution to the Great Silence. The paradox assumes that life, once it gains intelligence, will inevitably look to the stars. But that assumption is born entirely from our own planetary experience, from our particular path under an open sky. For a species born in a lightless abyss, the stars do not exist. The silence we perceive may not be a silence of absence, but a silence of profound separation. We are listening for voices in the wrong medium, across an impassable barrier of ice and assumption. The cosmos may be a symphony of minds, but all playing their music in soundproof rooms, unaware that anyone else could be listening. The most profound connection we could ever make might not be with strangers but with family. This 13th solution to the silence proposes a radical twist in our cosmic origin story. It is the idea of directed panspermia. the possibility that life on Earth did not spark spontaneously in a primordial soup, but was deliberately planted here. In this view, the seeds of biology, perhaps hardy microbes encased in protective shells, were sent on a one-way voyage across the interstellar ocean by an ancient civilization. They might have been aiming to spread life as a form of cosmic gardening, or perhaps our planet was simply in the path of biological debris from a long-forgotten interstellar accident. Either way, if this is a common process, it reshapes the entire puzzle of the Great Silence. We would not be searching for our creators, but for our siblings, civilizations that sprouted from the same ancient seed stock scattered across the galaxy. This creates a powerful explanation for the quiet. If a wave of seeding occurred at a specific period in cosmic history, perhaps when the galaxy became sufficiently enriched with the right elements, then most of the resulting civilizations would be of a similar age. They would be technological infants together, like a litter of puppies born in the same hour, all just beginning to open their eyes. We are not hearing advanced signals because, like us, everyone else is still figuring out how to build a radio. The parents, the original seeders, might be long gone. Having completed their project of spreading life, they could have transcended into some post-biological state, departed for another galaxy, or simply faded into history. Their children are left to grow up in a vast, quiet house, unaware of their shared heritage. This transforms the Fermi paradox from a question of loneliness into one of genealogy. Our search for extraterrestrial intelligence becomes a search for lost cousins. The signals we listen for might not be the sophisticated beacons of ancient gods, but the clumsy first broadcasts of other young species, stumbling onto the galactic stage just as we are. It suggests a universe not of isolated accidents, but of a shared, if distant, lineage. This idea also leads to a more exotic and haunting possibility. If life was seeded, what was the vehicle? Some scientists speculate about mysterious, naturally occurring structures that could carry life, like rogue planets ejected from their star systems, drifting through the galactic void for eons. But a directed effort implies something more, a vessel or a technology designed for the purpose. This nudges our imagination toward considering more unusual cosmic artifacts. Could some of the strange objects we see in space, like the interstellar visitor Oumuamua, be not natural rocks, but the weathered, dormant hulls of ancient seed ships, their mission long complete? The silence, then, might be the quiet of a nursery where many young minds are sleeping, yet to wake and call out to one another. It offers a narrative that is both unifying and isolating, suggesting we are part of a grand biological family tree whose roots are lost in deep time. Our entire search for cosmic companions rests on a single, unspoken assumption that life must be made of the same stuff we are. But what if the universe's dominant substance is not a passive backdrop, but an active stage for minds we cannot fathom? The 14th solution dares to propose exactly that. They are made of dark matter. We know this mysterious component makes up about 85% of all matter in the cosmos. It does not emit, absorb, or reflect light. It only interacts with the familiar atoms of our world through gravity, weaving the invisible scaffolding upon which galaxies are built. To our eyes and our finest instruments, it is utterly transparent. But what if within that vast, unseen ocean complexity can arise? What if dark matter particles, through their own subtle interactions over cosmic timescales, can form stable patterns, complex systems, perhaps even structures analogous to consciousness? The entities born from such a process would be all around us, woven into the fabric of space itself. They would live on timescales of galactic rotation, thinking thoughts as slow and vast as the tides of star clusters. Their art, their communication, their very cities might be the delicate gravitational dances we mistake for natural celestial mechanics. To them, our frantic chemical-based biology and our chattering radio waves would be as irrelevant as the rustling of leaves is to a conversation held in ultraviolet light. We are like deep-sea creatures living in a world of pressure and chemical senses, completely unaware of an entire civilization of birds existing in the open air above the ocean's surface. Our tools are designed to see the water, not the sky. Our telescopes listen for electromagnetic whispers, but a dark matter civilization would speak in the language of gravity, a dialect we are only beginning to learn. This idea challenges the very foundations of our search. It suggests that the great silence is not a lack of signals, but a fundamental incompatibility of perception. We are not alone in an empty house. We are sharing a house with roommates made of a different phase of reality, passing through the walls without a sound. It forces us to question what we even mean by life and intelligence. Must it be carbon-based, water-solvent, and light-seeking? Or can it be something far stranger, emerging from the hidden bulk of the cosmos itself? If this speculative vision holds any truth, then the most advanced beings are not distant points of light. They are the hidden architects of the galactic structures we admire, their minds as vast and dark as the spaces between the stars. This perspective dissolves the paradox by expanding the canvas of what is possible, suggesting that the conversation of the cosmos is happening on a channel we have not yet learned to tune. The final explanation turns the question back on us, the observers. Why do we find ourselves in such a quiet cosmos? Perhaps because a noisy one would have made our existence impossible. This is the Anthropic Principle, a meta-solution that ties many threads of the paradox together. In its simplest form, it states that we can only observe a universe that is compatible with our existence as observers. If the galaxy were filled with aggressive, expansionist civilizations, they might have colonized or sterilized our region long before Earth cooled. If Berserker probes were common, they would have swept through our solar system eons ago. The very fact that we are here wondering about the silence suggests that our cosmic neighborhood had to be quiet enough and safe enough for a species like ours to evolve undisturbed over billions of years. We are not seeing a representative sample of the universe. We are seeing the one slice of reality that allows us to be here to see it. This observer selection bias means the great silence might be less of a mystery and more of a prerequisite. The conditions that allow for technological intelligence may be incredibly rare, not just in space but in time. We might live in a brief window of cosmic peace between dangerous eras, or in a sheltered backwater avoided by more powerful entities. Our solitude could be the signature of a universe where life is fragile, and where lasting civilizations either learn supreme caution or do not last at all. It encourages a profound shift in perspective. Instead of asking where everybody is, we might ask what necessary conditions had to align for us to be asking the question at all. The silence becomes the background against which our own story was able to unfold. This journey through 15 solutions reveals not one answer, but a spectrum of possibilities, each a different lens on our place in the cosmos. From the chilling logic of the dark forest to the patient waiting of Aestivation, from the inward journey of transcendence to the simple vastness of space, these ideas map the contours of a profound unknown. They teach us that the silence is not an empty answer, but a question that forces us to grow. It challenges our assumptions, expands our imagination, and compels us to consider what kind of civilization we wish to become. Will we be a brief, bright flash that fades into the quiet, or will we learn to listen more deeply, to see more clearly, and perhaps one day to add our voice to the cosmic conversation in a way that endures? The great silence remains for now our greatest teacher. Each of these 15 paths through the great silence offers a different universe. One is a dark forest of lethal suspicion, another a patient dormancy waiting for cosmic cold, still another a nursery where we are the eldest children. The Fermi paradox remains gloriously unsolved, and that is its greatest gift. Its power is not in providing an answer, but in relentlessly questioning our deepest assumptions. Are we alone because the universe is dangerous or because it is young? Are we hidden by design or by the sheer, silent scale of everything? Each possibility holds a mirror to our own fears, our hopes, and our understanding of what it means to be a conscious being adrift in the cosmic ocean. These ideas, whether grim warnings or visions of pioneering hope, serve a vital purpose. They stretch our imagination beyond the confines of our pale blue dot. They force us to confront the profound fragility of a civilization like ours, balanced on a knife's edge between self-destruction and a destiny among the stars. In doing so, they underscore the incredible preciousness of our world, our minds, and this fleeting moment in which we can look up and wonder. The search must continue. We must build better telescopes, listen on new frequencies, and think with ever more creative courage. We must also tend to our own garden, protecting the fragile biosphere that gave us life and the chance to ask these questions in the first place. The great silence may be eternal, or it may be the quiet before a dawn we cannot yet see. But in the face of that immense quiet, our curiosity is not a weakness. It is our signature. It is the most human and perhaps the most universal response of all. We wonder, and in wondering we reach out. So tell us which universe feels most true to you. Does the dark forest chill you, or does the idea of being among the first fill you with a sense of responsibility? Share your thoughts below, and if you crave more journeys to the edge of understanding, subscribe for deeper dives into the mysteries that shape our reality. The cosmos is waiting, and the conversation has only just begun.